Yes. There are some people, Madhulika, Tanushka, US Angel, Anushka, and Shrutika. It would be awesome if you all could rename as batch underscore your name. Okay, awesome. Good evening, and let me know once you can see my screen.
You can see the screen.
Okay, awesome. Thank you. So just like last time, today won't be like this me talking and you are listening. I want this to be an interactive session. So today I've planned something like a little different. In fact, I haven't planned a lot. So as you can see, there are no slides. I'll be just writing stuff on the blackboard and you'll be doing stuff in your notebook. So I want to talk about yes, please do not annotate. If possible, maybe I can turn it off. Uh, yes, awesome. Okay. So now, today I'm going to be talking about my like last time I talked about computer science, right? I really also in mathematics I really love number theory, and so everyone knows what divisibility tests are, right? Can someone quickly tell me what a divisibility test is?
Yeah, the tests or the methods that we use so that we can confirm if this number is divisible by a number.
Right.
Without actually carrying out the division.
Awesome. So, can you give me some examples of some divisibility tests that you know?
Yeah. So basically, divisibility test of 2 is that the unit digit should be either 0, 2, 4, 6, 8. That of 3 is if the sum of the digits is divisible by 3, then the whole number is divisible by 3. Then for 4, the last 2 digits should be divisible by 4. For 5, the last unit digit should be 0 or 5, and so on.
And for 6?
6,
it should be divisible by 2 and 3.
And for 7?
There are many tests. One is like we multiply the last number by 2 and subtract.
Okay. Let's wait here. Yeah. So yes. Okay. Let's just go through all the tests that you told me one by one. So what is the divisibility test of 2? We check the unit digit and see if it is. Turn on your videos also. Yeah. Thank you. 0, 2, 4, 6, or 8. So can someone give a quick, like, why does this work? Can someone give a quick proof of why the unit digit?
All the multiples of 2 end with these numbers.
How do you know that? Maybe there's a multiple of 2 that doesn't end with 0, 2, 4, 6, 8. How do you know all of them end with 0, 2, 4, 6, 8?
Because these are even numbers, and a number is even if it is divisible by 2, and these all are the multiples of one digit multiples of 2.
Okay, say that again step by step.
Numbers divided by 2 will always have 0 as a remainder, and they are single digits.
So basically, we can say that if we have any number ending with the unit digit x and we multiply it by 2, we'll get either 0, 2, 4, 6, or 8. So therefore, this test is valid. So we can just try with all the numbers from 0, 1, 2, 3 till 9. So with 0, we'll get 0, 1, we'll get 2, with 3, we'll get 6, with 4, we'll get 8.
Awesome.
Like that.
So I'll just repeat once again. What is Anushka saying? Anushka is saying that whenever we multiply a number by 2, the unit digit is always 0, 2, 4, 6, or 8. So how do we know that? We can just consider 10 cases. One is that the unit digit of the number is 0. So when we multiply it by 2, we'll get a 0 again. The other is that it is 1. So we'll get a 2 again. For 3, we'll get 6. Okay, I missed 1. 2, we'll get 4. For 4, we'll get 8. For 5, we'll get 0 again. And for 6, we'll get 2. 7, we'll get 4. 8, we'll get 6. 9, we'll get 8. These are all the cases. So can the unit digit be anything other than 0, 1, 2 up to 9? No. Awesome. So with this means that, so what do we get? The unit digit either 0, 2, 4, 6, 8 or 0, 2, 4, 6, 8. Awesome. So, but how, okay, another question. Now you proved that if I multiply a number by 2, it will end in 0, 2, 4, 6 or 8. But how do we know that if a number ends with 0, 2, 4, 6, 8, it can be divided by 2? So let me try to ask this question in a nicer way. So what you're telling me is that if I multiply something by 2, I'll get something that ends with 0, 2, 4, 6, 8. But how does that tell you that if I take a number which ends with 0, 2, 4, 6, 8, and then I divide it by 2, I'll get an integer. So do you see the problem? This is only a one-way argument. I want the other way. So let me try to think of an example. I am saying that an apple is a fruit, but like now if I take an apple, you can know for sure that it's a fruit. But if I give you a fruit, you're not like, you don't know for sure that it's an apple. So it's something like this. When you're multiplying by 2, you know that at the end you get 0, 2, 4, 6, or 8. But when you have 0, 2, 4, 6 at the 8 or 8 at the end, how do you know that you can divide it by 2?
Ma'am, I think I have a proof. So can I just say mine?
Yes.
Yes,
Also,
ma'am.
Harini, can you like quickly rename yourself like once you're done talking?
Yes, ma'am.
Quickly.
Sorry.
Yeah.
Yes,
Yeah, it's
ma'am.
okay. Go on.
So, ma'am, we can write any number n as 10 raised to n a n plus 10 raised to n minus 1 a n minus 1, like that, where a n minus 1 dot 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 are the digits of this number n.
Wow. Okay, 1 second. How do we know this?
Ma'am, because this is the standard representation of any n-digit positive number.
Okay, so let's just wait a second here. Does everyone agree with this?
Yes.
Yes, the expanded notation.
Expanded notation.
Okay, go on. Yes, Harini, go on.
Ma'am, so now we know that 2 will divide 10 because 2 times 5 is 10. So 2 divides 10 a1, 2 divides 10 square a2, and 2 divides all the terms from 10 raised to n a(n) to 10 a1.
Right.
So this part of the number is divisible by 2. Now,
Okay,
if we
now
say that,
you're talking a lot of things. You're saying that 2 divides 10 a1, 2 divides 10 squared a2. Okay, I agree. 2 divides. Okay, let's say I agree for now. And 2 divides 10 raised to n an. So now you're saying that since 2 divides all of them, 2 divides their sum as well.
Yeah.
Does everyone agree with this?
Yeah.
yes,
Why is this true?
Yeah.
Yeah.
ma'am, we can write all of them as a multiple of 2 and take 2 common.
Yeah.
Awesome. Okay, because of the distributivity problem. I'm asking stupid questions, but yeah, bear with me. Yes. Okay.
Saee, what is that A2 and AN in this?
Okay. Good question. Very good question. So, these are just variables. Let's say we have so, okay. Harini, do you want to explain what is A0, A1?
Yes, ma'am.
Yeah.
So here A0, A0, A1, A2 till AN are just variables that we're using in place of the digits of a number.
So let's say we have like 563. Then what is the actual value of this? It's just 5 times 100 plus 6 times a 10 plus 3, right? So what you're doing is this is just 10 squared. So 5 times 10 squared plus 6 times 10 plus 3. This is the number.
So A0 is 3, A1 is 6, and A2 is 5.
Yes.
Okay,
correct.
I understood. Thank you.
Okay, that was an awesome question. Thank you for asking. Yes. Okay. Yes, Harini. So now we know that 2 divides this. Okay. Okay, now let's wait. Does anyone else can someone tell me what like Harini's argument is going to be next? Can someone read Harini's mind? Yeah.
Me. Yeah, so Anushka.
Yeah.
Yeah, so we have this whole number, and we say that from 10 to the power n an till 10 a1, everything is divisible by 2. So for the whole number to be divisible by 2, a0 should also be divisible by 2.
Okay. Do people agree?
Yes.
Yeah.
Okay, let's get a few more yeses. So maybe I can ask
Yes.
random people if they agree. Yes. Anvi, do you agree? Angel, do you agree? Tanishka, Sharmila?
Yes, ma'am.
Okay. Arushi?
Yes.
Yeah, okay. In the chat, I can. Okay, awesome. Okay, so now if we want the whole number to be divisible by 2, we want a naught to be divisible by 2. And we know a naught is a single digit number. So what are the single digit numbers that are divisible by 2? 0, 2,
2, 4, 6, 8, and yeah, 0.
Awesome. So yes, this was a nice warm up. Okay, now we also have the divisibility test of 3. What was it? Can
If
someone
the sum of all the
Sum of-
digits are divisible by 3, then it is divisible by 3.
Okay,
The
now
sum of
why
all
does
digits is equals to-
Yes, awesome. That is correct. So why does it work? Can someone tell me why it works? Okay, Harini will wait for some time. Maybe we can ask someone to read Harini's mind. So the sum, okay, Urvi, okay, let's wait some more time. Sum of the digits of n should be divisible by 3. Okay, let's see. How do we start? How should we start with this proof? Is everyone familiar with this divisibility test? Do you want me to take some examples? Okay.
Yes, ma'am.
Okay, awesome. Okay, maybe. Okay, how would Harini start this? Can someone guess how Harini would start this proof?
May I?
Yes, sir, go ahead.
Yeah, so she'll again use the expanded notation wherein
Mhm.
9-digit number and it will be expressed as 10 raised to n into an and
Okay.
raised to n minus 1 into a raised to an minus 1 and so on till a is 0.
Mm-hmm.
Later now she'll be using the fact that 10 like till a0 all of the numbers will be in multiples of 10, right? So
Yes.
we should give a remainder 1 into that digit because
Okay, why?
10 gives a remainder of 1 when divided by 3.
Okay, so now you're saying something which I don't know. You're saying that if 10 gives a remainder of 1 when divided by 3, then 10 times a1 will give a remainder of a1.
That's not yeah, like 1 into a1, yeah, right.
Hmm.
This is what-
Basically, we are telling that if one number gives x remainder and another number gives y remainder, then the product of those numbers will give remainder xy.
Oh, and why is that true? Why should I believe you?
Actually, this is one of our modular arithmetic when we
Yeah, rather than this, we can also say one more thing that if we have 10 to the power n an and any power 10 to the power n will never be divisible by 3 because 10 is never divisible by 3. So basically, whatever remainder this leaves will be irrespective of if we include 10 to the power n or we don't, because that will not make any difference because we are getting a product over here. So basically the an that will is the one which will give us it will be divisible by 3 or it won't be divisible by 3. So 10 to the power n does not matter.
So you're saying that if this was 11 to the power n as well. Oh, okay. So you're saying we can just ignore the 10 to the power n.
Yeah, because
Yes.
basically it does not divide 3 and basically we are finding over here a number that divides 3, but 10 to the power n for any value n won't divide 3.
Okay, what if we consider 11 to the power n? Okay, we'll come back to this. Let's go step by step. So, Urvi said something earlier. Let's try to see why she said that, and then we'll come to your point. So, what was Urvi saying? Urvi was saying that, and Anushka was also saying that, let's say we have two numbers. Let's say we have A and B, and A leaves a remainder of X, and B leaves a remainder of Y. Then AB leaves a remainder of XY. So, was modular arithmetic done in all batches? I think Kambe sir
Yeah.
put it in.
Yeah.
Was it done in all?
Yeah.
Okay, so was it also proved? Was this also proved? Why AB gives a remainder of XY?
Yeah, I think we proved it also.
Okay, can someone quickly run over the proof?
No, I don't think we did any specific proof for it. Like,
Okay.
Shrutika, we didn't prove it.
We just used an example. We didn't prove it.
Okay. Yeah, that is
that's what I'm saying. Not any such specific proof. So
Yeah, we just tried it.
Okay, so does everyone understand the statement?
yeah.
Yeah.
Yeah, Kirti, yeah, okay. Okay, awesome. So how should we try to prove this? Let's say that the remainder of when, okay. Okay, so do you want me to give you some time to think about it? Should I give you, let's say, 1 or 2 minutes? Do you want to try it
Yes.
on your own in your notebook? Okay.
Yeah.
So I'll wait a couple of minutes then. So in the meanwhile, maybe I'll just check on with Shiva Priya. Are you there? Okay. Let's see. Jyotsna, are you there? Okay. Okay. So, yes. Okay. Can you unmute? Is there any way? Are you comfortable with unmuting? Okay. I guess your mic doesn't work or something. All right. So, do you have any ideas, Jyotsna? How do you? First of all, do you agree with this statement? And second of all, how should we do it? Just some warm up stuff we are doing before we get into interest.
I think I found it.
Okay, awesome. So I'll just ask people, do you want to hear Urvi's proof or do you want to work more? Okay, these people are still working. Maybe you want to give them another minute or so. So I'll just repeat the problem again. We have two numbers A and B, and we are dividing them by 3. And let's say the remainder when A is divided by 3 is X, and the remainder when B is divided by 3 is Y. Then the remainder when AB is divided by 3 is going to be XY. That is the claim. So if let's take a few examples. Let's say we have 13 and 17. So the remainder when 13 is divided by 3, okay, that was bad. 13 and 5, let's say. The remainder when 13 is divided by 3 is 1, because 3 4s are 12, remainder 1, and 5 when 5 is divided by 3, it's 2. So when I multiply 13 and 5, I get 65. And when I divide 65 by 3, I get the remainder 2, which is 1 into 2. So it does seem to work here. All right. Maybe Urvi, you can start. How did you start with it? And maybe people can read your mind.
So I simply used the division algorithm. So I expressed A is equal to 3P plus X. Now, since we have considered 3 here, so I took it as 3P plus X. Similarly, B as 3Q plus Y.
Okay, wait, pause. So yes, does everyone see why we did this? So we have a division algorithm, right? Whenever, yes, awesome. Okay, so I won't repeat it. So we can write any number as 3 times some number plus the remainder. And similarly, we can do the same thing for B. Now, can someone quickly finish this off?
May I try?
Yes, sure.
So we can then if we multiply the brackets 3p plus x multiplied by 3q plus y, we get 9pq plus 3py plus 3qx plus xy. And we can write the first 3 terms common as 3 multiplied by some number, and the remainder we get as xy.
Awesome. So what Arya did was we want to study AB, right? So why not just multiply these? So what do we get when we multiply A and B? We get 3p plus x times 3q plus y. It's just 9pq plus 3py plus 3qx plus xy. And we can write it as 3 times
3p pq plus
Yeah.
py
Y
plus
plus
qx
QX.
awesome.
plus xy.
Yeah, plus qx plus xy. Which means that the remainder that AB leaves when divided by 3 is going to be the same as the remainder with xy. Like it's going to be the same as xy. Okay, is everyone satisfied with this? Does this make sense to everyone?
Yeah.
Yes, ma'am.
Yes, ma'am.
Okay, let's maybe I could hear a few more yeses. Okay, let's
Yeah.
Yes.
Yeah.
Okay, awesome. And will this proof work for any number? So not just 3. Let's say I want to divide by D. Can we use
Yeah, it can work with every number.
Yes, we can use this.
Basically, it would
Awesome.
become dpq plus dpy plus
Would it be DPQ?
Yeah, instead of getting 3 common, we'll get D common.
D
And in
common,
bracket, the
yeah.
first term will have the D term.
Exactly. Awesome. Okay.
And here, even instead of taking A and B as specific numbers, we have taken K as any arbitrary integer. Then
Mhm,
how would
mhm.
that work like? As a standard case, maybe.
Awesome. Okay. So yes, so now what we just proved was that if A leaves a remainder of x and B leaves a remainder of y, then AB leaves a remainder of xy. We have successfully proven this. Now let's get back. Yeah, sorry, Mansi.
वॉमिटिंग कर दूंगा बिल्कुल
Mute.
Okay, no problem. So yes, what was I saying? I lost track. Yes, now let's get back to the problem which you were trying to prove. What are you trying to do? You were looking at this. A1 times 10. Why did I start writing ulta? Okay. A 10 to the power n, 10 to the power n minus 1, an minus 1, all the way up till a 10 a1 and plus a naught. Okay, so we are now dividing this by 3. What will happen when we divide? Let's start from the right and let's see what happens. What happens when we divide a naught by 3? We can't really say anything, so I'll just keep it as it is.
Yeah.
What happens when we divide 10 a1 by 3?
A1.
A1.
The remainder will
Remainder
be
is
A1.
A1.
Remainder will be even.
1 into A1. 1 into
Yes,
A1.
1 into A1.
Okay, yeah, Shrutika, can you explain why it is a1?
Because you cannot 10 divided by anything by 3 will not give anything. Like 10 into anything by 3. So you don't need to consider 10 here.
Ah, okay. What if we had 11? Would you still not consider 11, Shrutika?
We would, because that will give us 2
But
A.
still, like if we are considering like just numerals, then suppose if we have A1 as 7 and then we cannot call 7 as the remainder when we are dividing it by 3, we'll further have to divide it by 3 and then find out the remainder which we get.
Right. So what we're actually, that is an excellent point. Arya is saying that if A1 is like 7, then the remainder of 10 to the 7 is not going to be 7. But can someone tell me but what?
Mod 7.
Exactly.
3 mod
What?
7.
Exactly. 7 mod 3. I mean, yes. What Kirti said is that essentially both of them are going to leave the same remainder when divided by 3. Does that make sense, Arya?
Yeah.
Yes.
Okay. So yes. So what if we had 11 A1? What is the remainder when we divide 11 A1 by 2? I mean 3.
I think minus
2 A1.
yeah, 2A1 or minus A1.
2 A1.
2A1, right. Awesome. 2A1 or okay, this thing has stopped working. 1 second. I do not want an eraser. Awesome. Just give me a second. Let me try to figure this out. Yes, no. One second, I'll just close this application and open it again. But yes, think about it. So we can either have 2a1 or would we also said minus a1? So why minus a1? Okay, this is still not working. It's very idiotic. I'll just share a whiteboard instead. Sorry, I'm not sure what happened. Can you see this whiteboard?
Yeah.
Yes.
Can I tell why it will
Yeah.
be 3k minus like a minus 1 or plus 2?
Sorry. Yeah, we have like 11a1. So it's 2a1, yes, but why? How can it be minus a1 as well?
Yeah,
Like,
so we can like first take 11a1 to be some 3k plus 2 type. 11 is some 3k plus 2, where k is like we just consider any number as 3k plus some number. So here it will be 3k plus 2. So we can write 11a1 as 3k plus 2a1.
Correct.
okay.
Now 3k plus 2.
I lost you. Is it my internet?
No,
Don't
I
tell me.
said 3k plus 2.
Yeah, but
No,
this in this
no,
case,
let's take 3 here, right? In this case, yeah.
Okay, yeah, we can
Yeah.
just write it k. So basically, we can after writing this, we can write 2 as 3 minus 1.
So this is just plus
As
3
3
minus
minus 1. So we can write that as 3 times 3 plus 1 minus 1. Yeah, that's 3 into 4 minus 1. So we can even write that as 3k minus 1 a1. So that will give us the like that will prove why we can write it as minus a1.
Uh-huh. So essentially, we are just saying what you're saying is 2 is the same remainder as minus 1 when divided by 2. So minus 1 remainder sounds very weird, but in a sense, it does make sense, right? 2 leaves 2 is like minus 1, like 2 is like 3 minus 1. So 2 leaves a remainder of minus 1 when divided by 3. So yeah, in the kind of it also makes sense. So what you're saying is if we had 11a1, then it's the same as 2a1, but 2 is also the same as minus 1. So it's also the same as like it will leave the same remainder as minus a1. But anyway, this was kind of off, like we kind of diverted, but yes, this was nice diversion. So we had this, right? Yes, let's get back to our main point. Plus 10 squared a2 plus 10 a1 plus a0. Yes, so we were dividing this by 3. And now a0 will leave the same remainder as a0. We can't really do anything about this. 10 a1 will leave the same remainder as
A1.
a1. Awesome. And what about 10 squared a2?
A2.
Why is that? What is the remainder?
Same way, like as we divide 10
A2.
by 3, we get 1. Same way, 10 square by 3 also 1.
Okay. Devika is saying something interesting. Since when we divide 10 by 3, we get a remainder of 1. So is everyone comfortable? Is everyone here comfortable with the modular notation?
Yeah.
Anvi, okay, I'll just ask random people as well. Ifam, Sharmila, Deepika, are you all comfortable with the modular arithmetic notation? Hello, people. Spandana? Okay. Shanmukpriya?
Yes, ma'am.
Okay, awesome. So yes, we have 10 leaves the same remainder as 1 when divided by 3. Okay, something in chat. Awesome. Okay. We have, Devika is saying that since 10 leaves a remainder of 1, 10 squared also leaves a remainder of 1. Can someone quickly give like a 5-second argument for why 10 squared will also
Yes.
leave?
Can I?
Yes.
So it is going to be 10 times 10. 10 square is going to be 10 times 10. So which will give the remainder 10 mod 3 times 10 mod 3, which is 1 into 1.
Awesome. Okay. Very nice. We have this. So a 10 squared a2 gets reduced to a2 and so on. So any power of 10 will leave a remainder of 1. Can you see it? By similar argument, Any power of 10 will leave a remainder of 1 when divided by 3. Because we can just keep on doing the same thing. 10 cube is 10 squared times 10, right? Or let's say 10 times 10 times 10. And 10 is just 1. So 1 times 1 times 1. Okay, right?
Yes.
Awesome. So we have 10. This 10 to the n minus 1 is an minus 1. And this an. So now what do we have? We now have that our number when divided by 3 leaves the same remainder as when, like if we add the digits and take the remainder. Both of these leave the same remainder when divided by 3. So what we had earlier was slightly weaker. We were saying that if the sum of the digits is divisible by 3, then our number is also divisible by 3. Now what we are saying is that whatever is the remainder when we look at the sum of the digits, the same remainder is going to be as of the original number. So if we have like 13, 13 leaves a remainder of 1, and like 1 plus 3 is 4, and that is also 1. Let's take a 97. 97 leaves a remainder of 1 because it's 96 plus 1, and 96 is divisible by 3. And if we look at 9 plus 7, that is 16. 16 also leaves a remainder of 1. So essentially what is happening here is both of these numbers, our original number and its sum of digits, leave the same remainder when divided by 3. Do you know of a similar divisibility test? A divisibility test which is very similar
Of
to
9. Of 9.
9.
Of 9.
So can you, would you be able to give a proof for that as well now?
Yeah.
Yeah,
Yeah.
similar proof.
Because
Yeah,
10,
it is very similar to this.
Yes,
10 gives 10 gives the
9.
remainder 1. Because
Yeah,
10
9
gives
is
the remainder
remainder
1 when we divide by 10.
Yeah.
So therefore it will essentially become the 1 into a1, 1 into n minus 1, and so on.
But instead
Sure.
of mod 3, it would be mod 9. I think so.
Yes,
Mod 9.
exactly. Awesome. Okay. So now, yeah, maybe as an exercise, as a homework, you can try to write down the proof of divisibility test of 9. But I'm sure like you all have got it. So now 11. We also know the divisibility test of 11. Right? Can someone tell me?
So you make the sum of the alternate digits, like the ones at odd places and the ones at even places, and the difference of those sums is divisible by 11.
Okay, so let's say we have 5, 6, 7, 8. How do I check if it's divisible by 11? I
So
take the
5 plus
alternate
7 and 6 plus 8. So 5 plus 7 is 12 and 6 plus 8 is 14. So 14 minus 12 is 2, which is not divisible by 11. Therefore, the number is not divisible by 11.
Okay, now can you try to give me a proof of this as well? Do you want to do it right now in class, or do you want to take it up as a homework
In class.
in class? Okay.
Yeah.
Harini already has it. Can someone read Harini's mind? Let's see. Harini, can you turn on your video? It would be awesome if we could see you. Yeah, and it goes to everyone else, not just Harini. Turn on your videos.
1 minute.
Yeah. If I can show everyone my face, you can definitely show everyone your face. Okay. Yeah, Urvi also has it. Awesome. Let's see. Okay, what should the first step be? Can someone tell me the first step other than Urvi and Harini? Yeah, it's nice to see you, Harini. Okay. Yeah, who was
I
it?
think the same thing that we used always.
Which is?
Writing it as 10 to the power n an plus 10 to the power 10 to the power n minus 1 an minus 1, so on up till a naught.
Yes. So it will be 10 to the power 1 a1, and then we'll have a naught over here. Okay. Okay, what next? Now we are dividing this by 11. Remember this.
I think I got it.
Okay, who was this talking?
Anushka.
Okay, turn on your videos now so I can see you next. Yeah, it's nice to see Spandana. Okay. Can kind of see her though, not exactly see her. Okay. Okay, Prerna. Hi, Prerna. Okay, yes, Prerna. What can we do next? I'm going to pick on you now. Yes.
So if we divide a naught by 11, you
Mhm.
get a naught.
Awesome.
So if we move on to 10 into a naught,
Uh-huh.
you basically get -1 into a naught, a1.
Oh, okay.
Because
Pause. Yes. Okay. Can someone else tell me why this is true?
Me.
Okay, maybe someone else who hasn't talked yet. Maybe. Mridula, are you there?
Yes, ma'am.
Okay. So are you following what is going on?
Yeah, kind of.
Okay. Okay. So just like feel free to pause and ask me to repeat anything if I am not making sense. Yeah. So what who said that? Yeah, it was I think Prerna. Prerna said that 10a1 will leave the same remainder as -1 times a1 when divided by 11. Does that make sense to you? Why is that true? Do you agree with it, first of all?
Yes.
Yes, okay. Arya agrees. What about Mridula?
Yeah, I know.
Okay, okay. Why is it true? Can you give a short argument?
I'll try my best. Like,
Uh-huh.
10 divided by 11 leaves -1 a1. So I suppose.
Yep, that is correct. That is awesome. Yeah, you're absolutely correct. So when we divide 10 by 11, 10, we can just write it as 11 minus 1, right? So in some sense, -1 is the remainder. Like, in some sense, -1 is the remainder when divided by 11.
Yeah. We can write as 11 plus -1. So it's the remainder.
Uh-huh. So a remainder is something that is always between 0 and 11, but -1 is a possible, like, -1 is not exactly the remainder, but -1 leaves the same remainder when divided by 10. It's
Yeah,
kind
we
of,
can-
that is the idea, kind of.
Okay, but why do we prefer -1 rather than 10 here?
Awesome. Can someone answer that?
Yeah, because it will be easier to calculate as we proceed further in this proof.
Yeah.
More simplified.
Okay.
Okay, so yes, what will happen in the next step? Here we had 10 squared a2. What is the remainder when we divide 10 squared a2 by 11?
It will again be
you get
-1.
-1.
No,
and
it won't be -1.
No, can be 1.
It is
It
going
will
to be
be 1
-1.
because
One.
because 2 is a even number. So if 10 leaves remainder 1, 10 to the power 2, that is 10 square, will leave the remainder -1 square, that is 1. So it will leave the remainder a2, not -8.
Right. 10
Yeah,
leaves
yeah.
a remainder of -1. So 10 times 10 will leave a remainder of -1 times -1, which is 1. By the way, another diversion which we want to do in class, why is -1 times -1 1? It's take it up as a homework. Maybe we want, like, it will be too much of a diversion to do it in class. But yes, have you ever thought about it? Why is -1
Yeah,
times
I
-1?
do know that.
Okay, that is awesome. So for those of you who don't, maybe you can try to do it. Yes, so we'll get a2 over here. And what will be 10 cube times a3?
Since 10 cube, that is 3
will
is
be
odd,
Minus
minus
a3
A3.
because again that is odd power.
Odd.
So
10
we'll
Right.
get another
Minus
minus
1
sign.
times -1 times -1. And this is just like -1 times -1 is 1, as we saw. And then 1 times -1 is -1. 10 cube this will give us negative a3. So can you see a pattern? A naught minus a1 plus a2 minus a3. What will be, okay, one second, let me just make a new page. Yeah, 10 to the 4 a4. What
That
will
will
it
be
be?
positive A4. Positive.
Plus
Negative
minus
1,
a4.
negative 1, negative 1. Then these two we can group up and these will become 1. These will become 1. 1 times 1 is 1. So this will just become a4. So if you observe this, what are we getting? This is exactly what a divisibility test is. We get a naught. We are adding all the even wale. Like we are adding a naught and then a2 and then a4. And all the even ones we are adding. And then from that we are subtracting all the odd ones. So what was the example that we took earlier? Oh, I erased it. My bad. But I think it was like 5, 6, 7, 8, right? So we start from here If you want to divide this by 11, the remainder is going to be 8, then minus 7, plus 6, and minus 5. So 6 plus 8 minus 5 minus 7, or I can cleverly just write it as 6 plus 8 minus 5 plus 7. Okay, did this step make sense? Did this step make sense?
Yes.
Yes.
Yeah.
Yes, ma'am.
Okay, so now we have again we have a stronger claim. We were only talking about whether or not 5, 6, 7, 8 is divisible by 11. Now I can tell you what the remainder is. I can tell you that the remainder when I divide this by 11 is going to be 14 minus 12, which is 2. Awesome. Okay, so yeah, this was mostly the warm up which I wanted to do. Yeah, awesome. Okay, now we can get into the fun stuff. So what is the divisibility test? So don't tell me a divisibility test that you already know. So we have 13. Does anyone know a divisibility test for 13 here?
I did know, but I forgot.
Yeah, okay. That is awesome.
You can multiply the last 4 digits of the number and add it to the remaining number formed.
Okay, and how do you know this?
No, this is just a divisibility test I heard somewhere.
Okay, you heard this somewhere. Okay. Maybe before looking at it, maybe can you try to come up with a divisibility test of your own? Okay, so now I'm just like blabbering. You might think I'm blabbering nonsense, but here is how I want you to do it. Maybe just try to look for patterns and just write the table 1, 3, 2, 6, 3, 9. And maybe just like try to look at this sum. We have 1 plus 3. This is very vague. Like this might seem like a lot of nonsense for now. Just
I
very
got it. I
Multiple
got it.
4.
I got it.
okay. What is it?
So basically, the sum has to be divisible by 4.
Aha! I proved you wrong here.
Last 2 digits will be divisible by 4.
No, that will not be true
Yeah.
because it's not there in 39.
Yeah.
Okay, just don't look at 4, 8, 12, 7, 11. Look at the relationship between 4 and 13, between 8 and 26, between 12 and 39, between 7 and 52. Okay, now let's say
They
I
have a
have
difference by multiples of 9.
Not exactly multiples of 9.
Because
okay. Who
13
said that?
minus 4 is 9.
Okay.
26 minus 8 is 18.
Yeah.
39 minus 12 is 27 and so on.
Is it something we did not expect? Is it like why is it happening? So while proving the divisibility test of 9, what did we do? So okay, we didn't actually prove it. Maybe I can erase this word.
But I don't think it works for 52.
Oh, 52 minus 7 is what? 45, right? 45 is divisible by 9. This is an awesome trick, but okay, maybe let me just.
45 is not like continuous multiple, but it is.
It's not the next multiple, but it
Yeah,
is
but it is the. Yeah.
Okay, so now, okay, but is this only restricted to multiples of 13? Look at 14. 14 minus 5, we get 9. Look at 28. 28 minus 10, we get 18. This is something that is happening everywhere. Let's look at 123. 120
Yeah.
minus 6 is what? 109. No, my subtraction skills are awesome. Yeah, 117. 117 is also divisible by 9. Why is this happening? Homework. Okay, this is something that is happening for all the numbers, not just 13. And you have to prove this for homework. But this was an awesome observation by Arya. Good job. What else can you see? So if I want...
Can I try?
Yeah, sure.
So if you take the first number, 13, 4 times 3 plus 1 is 13.
Okay, I see where you are going.
8 times 3 plus 2 is 26.
Okay.
And 12 times 3 plus 3 is 39.
Oh my God. Okay. Does it work for 52 though?
No.
7 times 3. So you're
Plus-
multiplying by 3 everywhere. So I'll just multiply by 3 again.
Here it is 7 times 7 plus.
We can write it as 16 times 3 plus 4.
What?
So
Yes, we can do that. But look at Prerna's pattern. What is Prerna doing? She's multiplying by 3 every time, right? So
yeah,
I'll
so,
just do that. And then what
so
should
we
I
can
add
also
here? I'll multiply it by 3 again. So 7 I'll multiply by 3. So what she's doing is, observe this. She's taking this 4,
7
multiplying
square
by
plus
3, then 8, and then multiplying by 3. I have no idea where she got this 3 from. Taking 12, multiplying by 3, and then 7, I'll multiply it by 3. And what should I add? What is she adding here?
She's adding like the number before. So if you add 5, you won't get 52.
But what are you getting? 7 times 3 plus 5, what is it?
26. 26.
Okay, does that blow you away?
That 26 into 2 is 52 by the way.
Yeah.
26 is also divisible by 13. Okay, this is freaking me out. Let's look at 65 and let's do the same thing. We first add the digits, we get 11. And then what do? We multiply it by 3, which I have absolutely no idea where Prerna got it from. I guess she just like did this. Ooh, look, I have 3, so I'm going to multiply by 3. And then I'll add 6. Right? 11 threes are 33 plus 6 is 39. Oh my god, 39 is also divisible by 13. I am blown away. Okay, let's see more. I can't believe this is happening. Okay, 65, what comes? 78, right?
78, yeah.
7 plus 8 is 15.
15
I
into
think
3
I have
is
an
45.
idea about
45
why.
plus
3.
plus 7.
Yeah, we add
52.
this.
52. It's 52.
52. Oh my god. Okay, I want to look at more examples. What happens after 78? 91, right?
91, yeah. 10 into 3 plus 9, that is 39.
I am blown away. Absolutely blown away. Okay, what happens after 91 though?
102.
104.
104.
Yeah, 104.
104.
Now what do? We add the digits? Does that work? 5 times 3 is 15.
Plus,
And then what do I add to 15? No, this is...
no, I think it should be 10 into 4 plus 10.
Oh,
10 into 4 into
10 plus 4. Okay. 14.
Yeah, 14 into 3
Plus
is
10.
42 plus 10,
Plus
52.
Oh my god, awesome. Okay, just excuse me for a second. Try to see what is happening here. I'll be right back. Yes. So did everyone understand what like Prerna said? Prerna, can you turn on your video? We want to see you. How did you come up with 3? How did you get 3? How did you get this 3?
You told me to find out the relation between 13 and 4.
Okay.
So the closest multiple of 4 is 12. And 12 plus 1 is 13. I just continued that pattern. And
I got the divisibility test using this.
Okay, so okay, wait, we didn't check if it's working. Like for over here, we had got something misleading. We had something that was working for everything. When we are looking at 13 minus 4, you're getting 9. 26 minus 8, you're getting multiples of 9. Is this happening? Does this work for numbers not divisible by 13? Let's look at 92 maybe. What happens when we do this for 92? 9 plus, can someone quickly turn on your videos? Where are you all going? Yes.
It's going to be 11 times
11 times
11 times 3
Plus
9.
plus 9.
And we get 33 plus 9. What is 33 plus 9?
42.
42.
42.
Not working.
Not working.
Uh-oh. That's sad. I mean, it is working, right? I mean, it is like, it's not sad. Why did I say that? It is working.
Happy. It's
It is
happy.
working
Yeah,
for
yeah,
it's
multiples of
working
13, but not for
That's the
other
result which we wanted.
But we can't find it
Exactly.
for digits more than 3 when, I mean, for deriving that, I mean, we can multiply 3 and then adding one number. We can't find it for huge numbers, right?
Oh, that's a good point. What if we
No,
have
you're
like,
adding the first digit, right? You're adding 9 here and you're adding 7 here and then 9 again. It's the first digit of the number.
We are just
right?
trying to prove we are just trying to get the divisibility test. So trying it for the first few numbers and proving it would be easier. So it's not going to be a problem. After we prove it, that's
I think what Dhani was saying is, correct me if I'm wrong, for huge numbers, let's say we have like, let's just take like a 3-digit number again. Oh, like 130 maybe, we know it's divisible, or maybe 143, just for the sake of it. How will we do it? Yeah, sorry for cutting you out, Kirti. But just, yeah.
14 will be 17. So 17.
14 times 14 plus 3, which is 17 times 3.
51 plus 14 is 65. And then,
Yeah.
no, let's say we had like another huge number, 1, 4, 3, 6, 5.
But see, the problem, how will you group it? That's a problem, right?
Yeah,
That's what I asked.
Yeah, that's what Dhwani asked. Okay, how will you
Yeah.
group it?
Is it something like to 7? I feel because of the grouping part.
Sorry, say that again, Kritika.
It's like a little similar to the 7 divisibility rule because of the grouping.
I don't know the divisibility rule of 7.
Maybe.
What is the divisibility rule of 7? We'll get to it maybe. So, right for now, no one knows the divisibility rule of 7.
Saee, maybe we can try to find a pattern, right? Because 65 again leads us back to 39. Am I right?
65 leads us back to what? 39. Yes.
I think, yeah. So we can try to find a pattern after how many numbers is it leading us back?
Okay.
And
But like, how do we check if this number is divisible by 13 or not?
So I'm like, if we take 13 for the say, it's the first one, and it gives, and 1 minute, yeah. So 13 would be 1 plus 3, 4 times 3, which is 12 plus 1, which is 13. Yeah. So and
Yeah,
then we go
that's
to
okay.
yeah. So for 26, we know for 26 it again leads us back to 1 minute.
Yeah, it's okay. Take
So
your
for
time.
26 it is
Maybe you
going
want to do it on your notebook first and then say
Yeah.
it. Okay.
No, my point is that we can try to after the 65 is coming back to 39 and 52 is coming back to 26. So after every 3 numbers, it comes back to the previous one.
That's what even I wanted to say.
Yeah, so it's going to be like we can just find it out.
Is it true for large numbers though? Is it true? Like what will happen to?
I tried all the possible group pairing for 5-digit number, but it's not working.
Oh, which 5-digit number did you take?
I just multiplied 13 by 999 at the calculator and I got 12987. Then I grouped it as 1 plus 29 plus 87. I grouped it at 12987, 12987, but it's not working.
Okay. Did you try everything though? So for 104, what worked was we took 10 and 4, right?
Yeah, but when I tried with 4-digit numbers, it is working like first 2 and last 2. I mean, I got
Oh,
everything
interesting. So which 4-digit number do you want to take? What is 13?
I took 13 into 102.
Which is like 1326, right?
Yeah.
Okay, that is why it worked. Because you were taking something. Consider 1430.
1, 2. Okay, yeah. Then we'll get 44 into 3 That is 132, and then 132 plus 14 is 146.
Is 146 is not divisible by 13.
No, it's not.
So,
So
yeah.
if we take 1, 4, 3, and 0.
So you're saying we group like this. So okay. So what is Anushka saying? Anushka is trying to figure out how we can group it for 4-digit numbers instead of 1430 is also a bad example. Let's just take 1443. Yeah, that one's better. So what is Anushka trying to do? She's trying to group 4-digit numbers, and she tried it grouping the first two and the last two, but it did not work. So now she's trying the first three and the last one. Yeah, Dhwani, you want to say something?
What I wanted to say was the 5-digit number. I tried it. The way I tried it was that 1298 and 7. So 2 groups I took it. So you should not include, the last digit. So 1298 plus 7 we get it as 1305. So 1305 into 3 plus 1298, I got it as 5213, which is divisible by 13.
It's working, ma'am. If we just take the last digit and all the other digits, it's working. Even with 1443, it's
For
working.
1443, even if you take just 14 and 30, sorry, for 1430, for example, the number is 1430, you're taking 14 and 30, you're grouping it.
Yeah, 54.
Yeah, 54.
44.
Yeah, 44.
Yeah.
So 44 into 3
Mm-hmm.
plus a 14.
What
So
is it?
146.
146 is not divisible by 13, right?
I think she took it as two digits. We should not include 0 alone. So 143 should be taken.
Actually 143 and 0 will give us the right answer, and even 144 and 3, that will also give us.
I think you should do the grouping with you should leave the last digit and then you should group the rest and then you should do the addition.
Exactly.
Yeah, that is the point. Yeah, with if with 1443 we get 585, which is 13 into 45.
That is awesome. So what all of you have come up with some divisibility test, which you are claiming is the divisibility test. 1 second. I am sorry. I am sorry for all the intrusions. There's no one else at home right now, so I have to take all the calls and stuff. But yes, so now you all together came up with this awesome divisibility test for 13 on your own. You should name it the AGMNC divisibility test. So we have this. We have what is, so let's say we have any number. Let's take a big number. Let's say 5. Okay, just give me some number, you all.
1286.
Okay, I just wrote down the digits I heard. So we have this. How do we check if it is divisible by 13?
You take 1, 2, 8, 4, 9, and 6 separately.
We add both of them.
Yeah.
1, 2, 8, 4, 9 plus 6.
1, 2, 8, 5, 5.
1, 2, 8, 5, 5.
And then
Multiplied by 3.
Multiply by 3 and add
add 1.
1, 2, 8, 4, 9.
Yeah.
Awesome.
I think we should repeat the process because then you'll again end up with a pretty large number.
But it will be.
So it's similar to the divisibility rule of 7.
Yeah.
Exactly. That's
Okay.
what
So we have to
So
I
I
think
don't
it
know
will
where you are
take less
getting
time
from.
to solve the actual division than
this
using
is
the
5
test.
and this is 51414.
Yeah, okay. So I'm not interested in the answer, but yeah, thanks. I was just writing it down so that you all know. So someone said that it's better to actually do the division instead of doing this. Well, yes, that is true.
That's correct.
This is true. But yes, this is something you all came up with. Now I have a question. What if, so what Prerna did here was she looked at 1 plus 3 and then she took 4 and she looked at a multiple of 4, which was 12. What if instead of 12, I looked at 16? How can I get 13 from 16?
Minus 3.
Minus 3. Awesome. And is the same pattern working for everything now? Okay, so let's see. we first did 1 plus 3, and then we multiplied it by 4. 4 4 is 16, and minus 3. We got 13 again.
That should work.
26. We did 2 plus 6, 8. Then and we multiplied by 4. 8 was a 32. And minus, I'll subtract the last digit, which is 6. 26 again. Voila. 39. 3 plus 9 times 4. 12 was a 48. Minus, I'll subtract the last digit. We'll get 39. Okay, let's try a couple more. 52. 5 plus 2, 7. 7 4s are what? 28.
28.
Minus 2 is 26. Yay, it does work. How there's like a party face emoji. Yeah, I'm ruining it anyways. Yes. Yeah, so we have this. Is this one slightly better than the last one? Okay, is there like a, can we just make this test faster so that, like, how can we make this test faster? Is there any way for us to do that? I'll just turn on the lights. Yeah. So is there any way for us to like make this method faster? Can we do it all in one step instead of going through all these numbers? Okay, so we have lots of questions right now. So question 1, can we make this faster? Excuse my very beautiful handwriting, which explains why I used slides last time. And then we have second question. Why does this work? And okay, I'm getting lots of questions. Are you guys getting any questions? What about other primes? Wait, can you all hear me? Yeah.
Yeah.
Okay.
Yeah.
I thought of trying the same instead of taking it as 13 and doing, we can take it as some other number, like any number, and trying it out.
Ah, okay. So instead of a prime, what if we consider composite numbers? Or does it work for composite numbers as well? Okay. What more questions are you getting? Or are you getting any answers to any of these? I swear my handwriting in my notebook is a lot better than this. I don't know why it's looking garbage here.
Actually, I'm getting a question, but
Yeah.
what is so special in 4 and 3?
Good question.
Why does it work, right?
Why 3 and 4? Where did you get these? Why 3 and 4? Do other numbers also work? Is there any quick way? Okay, so my thoughts are running faster than my hand.
It was my question was supposed to be this. Why 3 and 4? The other numbers meant these.
I see. Okay. Do other numbers work? So I'm sorry for not getting the question. And then I had another question. No, I didn't go. It ran off. Okay. What was my question? I forgot my question. Okay. Hopefully it will come again. So you can just start working on any of these. Maybe you want to try if this works for other primes. Maybe if you want to try how can we like make this faster. And I can't believe it's been an hour already. Okay. Yes, so it's 5 o'clock and we only have 25 minutes more to go. And why does this work? And what about composite numbers? And I had a really nice question. I forgot what it was, unfortunately. Excuse my very nice memory. Yeah. So which one do you want to work on right now? Do you want me to give you some time to work on individually? Or do you want to work together? Yeah.
Together we are taking 17 as another number.
We'll do together.
Okay. Yes. Okay. Devika is saying something. 17. Okay.
Here also the same way 1 plus 7 is 8. 8 into, just like we take 3 and 4, I just take it as 2 into 2 plus 1.
Mm-hmm. Excuse me. Yes, awesome. So this also works. Does this work for, so Devika just came up.
I just
She
tried
just took
it
it
for
randomly.
34.
Oh yeah, Devika, how did you get 2? Where did you just like do this and you had 2?
Actually, last like we found 3 and for this like this, I also found 8 into 2 plus 1 is 17.
It doesn't work for the next number, 34.
Okay, 1 second. We'll
It does
see.
not work
So what?
for
1 second, 1 second, 1 second, 1 second. Sorry. So we had 1. How did you get 2? So Devika said that she looked at 8. And can you tell me a multiple of 8 which is close to 17, Shrutika?
2.
2.
16. Yes, which is 8
Yeah.
times. That's how she got 2. Okay. Is that okay? Yeah. Then we add 1 and we get 17. So yes, so you're saying it doesn't work for 34. That's a challenge to Devika. Devika.
No, here the 3 plus 4 is 7. 7 into 2 plus 3. 14 plus 3.
3 plus 3. Okay.
Here first number.
Yeah,
is
you're doing the first digit, right?
Yes,
Okay,
yes,
okay.
yes.
I added 1.
Okay.
Okay, so we have a divisibility test for 17. That is awesome. But this is still taking too long, don't you think? We need a quick way. What if we had like a really big number? 1, 2, 3, 5, 7, 6, 4, 9. It will take us forever to like reduce this number to some number we know which is divisible by 7.
Yeah.
Okay, I have a question. Wait, Anushka, the Anushka from Pune. Were you there in the BMTSC camp when I talked about this?
From Pune? I'm not from Pune.
Yeah.
I'm from Mumbai.
Sorry, from Mumbai. Were you there in the BMTSC camp when I talked about this?
No, I think you had done something about Ramanujan somewhere else there.
Okay, awesome. Okay, then that is good. Okay, you didn't get any repetitions. Okay, that's nice. Yeah, so is there any fast method for us to do it? So everything to do it in one step.
So we do know that this works for other primes also if we try.
Now, how do you know that it works for other primes also?
I'll just try that once again.
Okay. Just try it out for all the primes and let me know. How many primes are there, by the way? How many primes is it?
Infinity.
Infinite.
Do you saw the proof of that? Did you see the proof of that?
I
No.
kind of know the proof.
Okay.
I have heard the
So
proof, but I'm not like thorough with it.
And okay, off-topic questions. How many primes are there?
I got a divisibility test for 19.
Okay, you got one for 19. That's awesome. Now, can you try to prove it? Why does it work?
Okay.
So I just want to know, like, what are you all working on? Okay, let's see. Padma, which question are you working on? Are you finding this interesting or is this like really boring? Okay, I hope this is not boring you. Anushka Tonapi. Then there's Dhwani. Are you all there? Tejasvi.
Yes, I'm here.
Masufa. Okay, yes. So which question do you think is the most interesting one? What are you working on?
I'm thinking on how many primes.
Okay.
I'm thinking on the third one. What about the other primes?
Yeah, same thing.
Okay. Well, I am the most interested by the first one because
First one,
even
yeah.
if we like have other primes, what is the use of this if it's going to take us forever to do it?
Yeah.
Yeah.
First one is the most interesting one, but then the
Okay.
others are also nice to work on.
Mm-hmm. Okay, maybe we can like wait another couple of minutes and then we can discuss about stuff. Okay, let's like maybe 2-3 more minutes and wait. In the meanwhile, just feel free to unmute and talk about like any of these questions or whatever you're working on. If you find something interesting, or if
I don't know, but it's working for all primes with something similar. Basically, we add the numbers, the digits, then multiply it by some number like 2, 5. It comes as some number and subtract the 10th digit.
Okay.
Or 1 digit. Yeah. subtract or add tens or one digit.
Interesting. So it does seem to be working. We don't
I
know.
got it for 19 and 23.
Okay. Does seem
Yeah, even I got it for 19.
awesome to be working. Maybe. We don't know. So if there are infinitely many primes, how are you going to check for all of them? Okay, that's another question for you to think about.
Like the same method does not work for all the primes. Like there is
Yeah.
slight change.
Format is same.
Mm-hmm.
And
You cannot use the same multiple. Like for a few.
Yeah.
So that's
So how cool is this? You just came up with a divisibility test for prime numbers on your own. I am very impressed by everyone.
Has anyone followed this or discovered this method before?
Unfortunately, yes. Maybe like unfortunately and fortunately, yes. It hasn't discovered before. So I know it. I like lots of people have discovered this before. So do people know about Vedic mathematics here? Can someone?
yeah.
What is Vedic mathematics?
Yes. Basically something about mathematics that was written in our Vedas.
Yes. So
So we have
surprisingly,
some
Vedic
tricks and like
Tricks and
some
yeah.
easy methods to do addition, subtraction, like all the different operations.
Yeah.
Maths.
Okay.
Which was
So
actually
now,
used back then, like
yeah. Sorry.
which was actually those methods were actually used like long time back.
Okay, so now I'm going
Yeah.
to tell you the ultimate truth. Get ready for a history lecture on Vedic mathematics. Vedic mathematics is only 100 years old, and it was so it's not very old. It's written by Swami Bharati Krishna Tirtha Maharaja, and he actually had he has done so much stuff. Oh my God! So he was I think he did his masters in 8 subjects and passed in with distinction in all of them. And during his time, so India was under British control, and also he studied the Vedas, and from the Vedas he got to know. Okay, no one knows how he got extracted that mathematics from Vedas. There is actually no math in Vedas, but somehow he managed to extract that mathematics from Vedas. And yes, and he wrote 16 these big volumes of whatever he understood. And then, so he was also working as an independence thing, right? Because India was under British rule. So he got into jail because of that, sadly. And when he came out, he all those 16 fat books were gone, just vanished. So, and all his hard work was gone. So what he did was he just wrote one Itusa book, and then trying to summarize what all those 16 books said. And that is all we know about Vedic maths today. So that book is still in publication, and you can find it online if you search for Vedic mathematics.
Yeah, I have that book.
Yeah. So it is awesome, and it's not very old. So yeah, so it's not old at all.
Where are the 16 books now? But
They're nowhere to be found. So you know Shakuntala Devi, right? She was a big mathematician. She claimed to have one of those volumes, but no one knows because she's gone now. So yeah, that's awesome. You all seem to already have the book. But yes, it's not only about tricks. It is also Vedic maths covers stuff till 12th grade, and even after that, it's not just about addition and subtraction and multiplication. It has polynomials, and it has trigonometry and all those stuff. So the Vedic maths is not just tricks. History lesson complete. Any questions? So yes, yeah. Okay, Shritika, you want to say something? Your hand is up. Okay, that's okay. So yeah, maybe we can work on the first one, and then maybe we can stop. Only 15 minutes remaining. So here's some. Yeah.
I really don't get how you find out the number which you have to multiply with.
Okay. So let's take an example. 29, and we add 2 plus 9, right? And we get 11. So what do you think we should multiply 11 by?
2?
3.
2, but then if we multiply by 2, we get 22, and we can't really add anything to it to get 29, right? Maybe we should try 33. Oh, wait, see? Okay, who was saying it works for all the primes? I don't see a method for 29. Try to find a method for 29. In the
What
meanwhile,
we can do is 22 plus 9 minus 2.
okay, does it work for everything?
Let me check.
58. So we'll do 13 times 2 plus 8 minus 5. 13 to the 26 plus 3. It does seem to be working. Okay, this is genius. So we're just trying to like throw stones in the dark is what you're trying to do, Sritika. We just look at random multiples of this and then see what we can do with them to get the same number again. Kirti, yes.
It does work for some composites also.
Awesome. Okay. You want to give an example?
I think it works for 22.
Okay.
Yeah, so it's going to be 4 times 5 plus 2 from the starting, which gives 22 again.
Okay.
44, we get 8 times 5 plus 4, which gives 44. 66, it's going to be 12 times 5
66.
plus 6.
Yeah, it does work.
And it's also
No,
multiplied by 5.
110. What happens to 110?
110.
That will be 11 plus 0.
11 plus 0 times 5
Plus 11.
Plus 11. Okay. 66. Okay. So
actually, it will work for both if we take the first digit or the rest of the digit.
No, the rest of the digit doesn't work, right?
No.
Yeah, when it is a 3-digit number.
No, like I mean, if we just do 11 plus.
It works. So
all the doublet numbers like this 22, 44, 33, it works.
Maybe it works for all multiples of 11.
Oh, that's interesting. There's
All the factors should be only prime numbers.
33, it's going to be
it works for 33 as well. We don't want that, right? It's
for
working.
all doublet numbers and in the 5 plus
but
the
I didn't
first
get
number.
the proof for 11. So
Oh, you didn't get the proof for 11?
yeah.
Okay, that's completely fine. Okay, we'll get to it again. So we'll get to it at the end. So just stay back at the end, okay? Yeah, Tanushka, you want to say something?
For 27, always the multiples, the sum of the digits add up to 9.
Okay, can you give me a quick proof of why that will happen? Why do all the multiples of 27? Okay, is that true though? 54 and then what comes after 54? My
81.
addition is bad. Yeah, 81. 108. Yes, 135. Okay, it seems to be working.
So whenever you multiply that by 3, you always get
see, 189 is a multiple of 27. The addition does not give you 9.
But it gives you 27.
It gives a multiple of 9. It gives a multiple of 9
or a multiple of 9.
Okay, why is it happening? There's a quick 5-second.
Because
no, it's like the first 3 numbers have till 9 and the next 3 add to 18, the next 3 add to like 27.
They will have to be a multiple of 9, and that is why if it is multiple of that is, it is common to.
Yeah, this is an awesome observation, Tanishka. Good job. So there's yeah. Okay. I get it that you get it. I get it that you get it. So for those of you who don't get it, try. It's a 5-second proof. Okay, so now I know like all of you have awesome observations to talk about, but I just want to, did anyone try the first one? Because if no one tried the first one, there is absolutely no point in what we did for the last 1.5 hours. Okay, so now since no one has tried it, I am going to ruin it for you. Or do you want to work on it on your own, or do you want me to ruin it for you?
Work on our own.
Okay, so if you get it, you can email me. If you don't get it, if you want to know what it is, you can email me. You have my email address, right?
Could you say that again, please?
What's the question? Can you please repeat?
Yes, so basically we want to like do everything in one step instead of, so when we had like a larger number, right? When we had like 5, 6, 7, 1, 4, 9, then we were looking at this and then adding this, then we were getting some another 5-digit number, and then again adding it and then getting a 4-digit number, again adding it, getting a 3-digit number and blah 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 and so on, right? It was taking too many steps. It's better to just divide and check if it's divisible. That is what some people pointed out. So is there any way we can do everything in just one step?
Can we convert it to n? Like, can we keep it in a universal way and then find out something?
Sure, you can try that out. Why not?
Using n digits or using like the expanded thing that we've been doing so far.
That's an awesome idea. Maybe, yeah, sure. Another thing, okay, I'm not sure. So how have you girls interacted with each other? Maybe you can find someone who wants to work on the same problem as you and you can meet up in the
We have a
weekly.
group.
Yeah, okay. So what you can do is maybe if you want to work on these problems with someone else from this group or just other people, you can just put a message in the group and organize a meeting where all of you come together to solve these problems together. So usually at the camp,
all 45 people are there.
yeah, no, not all 45 obviously won't be able to come, but those people who can come.
No, even in the group, they're not there. That's the problem.
Oh, maybe. Okay, so let's see.
Many people are not in Discord. That's also there.
No, not on Discord. Is there a WhatsApp group?
We have a WhatsApp group for
but all the members are not there.
Yeah.
Even
not JNB. Not JNB.
Oh, I see. So is everyone there on the Google Classroom then?
But that's batch wise.
Yeah, but that's
batch wise also.
That is
even
sad.
That's because we have interacted more with our group members, right? So it's like batch wise.
That is kind of sad. So you can. Yeah. Okay. I don't think everyone is there on Discord. So
yeah, not everybody
is not there in the WhatsApp group. So can someone add her?
Yeah, we need numbers. That's the problem. But I think they have to share it like.
No, actually, the WhatsApp group that is there for AGMNC is like managed by the admins. So I think only non-JNV students are only there. So all the people who are not there in the group might be JNV students.
Yeah, possibly.
And it's only of C group. Yeah, so that's the thing.
Okay, so I don't know how you can do this. Another homework problem for you guys. If you want to work together, it's another homework problem.
Can you show that slide of all the questions just once?
Yeah, sure.
Okay.
So it's another homework problem for you guys. Figure out how to meet up and solve these problems.
Okay.
You can talk with someone maybe. Yeah, okay.
We'll try within our group. I think that'll be easier because we have numbers of our group and are like that'll be more easier to contact.
Yeah, maybe smaller groups of 5 or 6. That will be good.
Yeah, that would be better. So each batch can work inside themselves, right?
Can I say something?
Yeah.
Yes.
If you want all to meet on a particular date or timing, I can manage a Zoom meeting. The same link we can use another day or something like that.
That would be great, Neha. Yeah, thanks.
Yeah, but let me know the timing and the date because other meetings are also same account, so I need to manage that.
Yeah. So what about?
So yeah, so now you all, Neha has agreed to help you out. So it's up to you to decide a timing and let her know. Yeah, so our time is up. So like 5 minutes to go. What do you want to do? Yeah, how can you contact Neha? Neha's number is there somewhere.
Yeah, I'm in the group as well. I'm in the Google Classroom as well. So you can just message. The JNV students can comment or something in the Google Classroom, and others can message in WhatsApp group. Okay.
Yeah. So
Saee, could you share your email ID?
Yes, my email ID is this.
Thank you.
Yep. So this subject is something that's really close to my heart because once when I was younger, I was solving some boring algebra problem and I got so bored that, oh no, it wasn't an algebra problem. It was I was trying to divide something by a prime number and it was so irritating that I didn't know if I was like if the number was divisible by or not. So I didn't know the divisibility test for 7 or 13. So I just randomly started playing. I added 1 and 3 and I got 4. Oh, I'll look at multiples of 4, just like plain not hot. And then I went on and 4 3 are 12 plus 1 is 13. I was blown up. Then I looked at 26. Oh my god, it works for 26. And then I don't know. And then a year later, so after that I did RAM TP, right? Phasing a methods and training program. So I had some tools. So a year later after that, I was also able to prove those divisibility tests. And I was like, wow. But unfortunately, my mother knows Vedic math. So she was like, I'm sorry to disappoint you. You did not come up with these on your own. They are in this book. So I took that book and I studied. So it's not the exact same, like it wasn't the exact same one in the book. So the book also tells you how you can, don't look at the book, by the way, if you don't want your life to be ruined, come up with it on your own. The book also tells you how to come up with those constants like 3 and 4. Like for in the case of 13, we had 3 and 4, right? The book also tells you how you can come up with 3 and 4. So don't look at it yet if you don't want your life to be ruined. So it was so much fun when like you came up with it on your own, right? The joy is just unmatchable. So it's like nicer when you come up with it on your own rather than when someone else tells you. So even in school, you can try to make stuff more fun. Like if you find stuff that is like very easy, I'm sure what you do, maybe try to come up with proofs. So most of you all must be knowing Pythagoras theorem. Why does it work? Why do we get a square plus b square is a square? So
I don't know.
yeah, okay. And then like I talked about earlier, why is -1 times -1 1? So just even by questioning the simplest of things, you can go really deep into mathematics. So yeah, that's most of what I wanted to talk about. And thanks for making the session so interactive. I had lots of fun. You all are very impressive people. And all the best for whatever you do in the future. Yeah, I guess that's all. I guess. Do you guys want to talk about anything else? We can stop the recording.
Yeah, okay.